Again, welcome everybody to DjangoCon. I'm excited to be here. My name is Hendryx-Parker. I'm CTO and co-founder of 6 Feet Up. We are a Python and AI for good consulting agency. And if you've seen us walking around today, we've been wearing our impactful campaign where we've actually been working on 10 impactful projects in 10 years. And the case study for this specific presentation will actually include some information, not all the names have been changed to protect the innocent, about one of our impactful projects, which is around energy storage. So if you're wanting to follow along, there is a GitHub repository associated to this talk as well. If you're just wanting to get the link, it's underneath the 6 Feet Up GitHub organization. Just look for the DjanCon US powering energy storage URL, or else that QR code will also take you to the presentation. And the link will be also at the end of the talk, so if you want to refer to it, it'll be there as well. But let's kind of start talking about energy storage projects specifically. For this specific customer, think about your power plants. They're cold generation or hydroelectric or wind or solar. They produce energy, but they need to put energy someplace sometimes. Typically, they're putting it on the grid, and so going into your houses. One of the big advancements we'll see coming, I think, in the near future is going to be longer-term energy storage, so that we can go and stockpile energy when it's nice and sunny, and then use it throughout the day. So right now we don't have those kind of capacities typically at our power generation points. So this specific customer actually has built some unique and innovative ways to store short-term power storage. And so every project in this case is a multi-step process of figuring out what that sizing looks like. These calculations typically have to account for 20 to a 25-year life cycle on the batteries that they may put in place at these power generation points. So these are not like battery systems you would put at your home. These are much bigger systems that are meant for kind of backing up the power grid itself. So it requires a lot of calculations to figure out how these batteries perform over time and understanding how they're going to actually fulfill their commitments to the power generation companies that are buying these kinds of hardware. So these kinds of things need to be able to predict degradation over time, understanding those kinds of curves, and calculate what are called tranches. So tranches are like slices. It's a French word for slice. And so these are basically how they deploy more and more batteries over time. If you wanted to guarantee a certain delivery power, you wouldn't want to, because batteries, the way they degrade over time, you wouldn't want to put all that battery in at once because it'd be too expensive. So if you were saying over 25 years, we guarantee a minimum level of power battery capacity, you'll want to know when you need to lay in, the next tranches of batteries as you go. So that's kind of what this is all about, is like new hardware needs to be added, but you want to keep the system always operating above the minimum requirements. And so you don't want to add too much hardware at any one point because that's just too expensive. Plus the price per watt for battery storage, as you know, with technology, everything gets cheaper, every year, in the future. So to do this, they built a slew of Excel sheets. As a startup, you want to go move quick. So basically they built a whole array of Excel workbooks that like simulated all these various calculations for the kinds of the amount of battery capacity would be needed for any one specific project, the pricing for those kinds of things, the bill of materials that would be required, and they had just incredible Excel workbooks put together to do these kinds of calculations all over across the various projects they're doing. But for using Excel in this case, obviously it's easy to get started with Excel. It's most people, if you've signed up for Office 365, it's included. You've got some kind of a spreadsheet on your computer. Typically, when you pull them out of the box, whether it be Excel or some other spreadsheet technology, but they're easy to get started with. It's super easy to bootstrap into, and especially if you're a small company of just a handful of people, it's easy to share. Like you put it on a shared drive and away you go. People are now calculating battery capacity storages and running their businesses on Excel because it was very easy to get started. The friction of the first movement is really, really easy to do. And then, you've got a rich ecosystem of tools built in. So rich sets of formulas, like fast calculations. You can basically use references across multiple sheets, even multiple workbooks. You can include references to external data. And even now, you can use Python in the macros to build even more exotic behaviors into your Excel spreadsheets. But then you end up with a problem, is you have tables and tables and tables and tables that get really, really hard to manage. But that's not the only problem. I think if you look at the real kind of why not to use Excel arguments, though, is that Excel is great for a handful of projects, but as soon as you get into, say, thousands of customers, and maybe you're using an Excel spreadsheet per customer, you can see where the scale of managing the versioning of the files can really become a big roadblock to productivity. And another problem is, what version are you working on? You could have 10 versions of this live across 100 customers and have mismatches in the formulas and basically end up with potential disasters on your hands. And then versioning with file name patterns. Us as developers have been long accustomed to using source control, and we love it. And using conventions like tagging and naming for versioning is all fun and good. But a lot of people who are using Excel don't have kind of that savviness with those tools. I mean, you could check it in, but I think a lot of people just default into the my Excel sheet .latest and or some date timestamp in there, or V1, V2, V3. So you can imagine where that can also get very hairy and tough to manage. But a bigger issue may even be if what you're putting into these Excel spreadsheets is kind of your secret sauce of how you operate your business. You're one email forward away from, or one errant share on your Dropbox or whatever file sharing service you're using, away from sharing out your corporate secrets with the rest of the world. So securing that business logic, could be really an important aspect of why not to use Excel in this case. So another problem is that there's not a lot of access controls on Excel spreadsheets. I've seen some pretty fancy ones, but there's a lot of hacks to get around protecting content on sheets. But everyone basically has the ability to change the content on any cell in any formula. There's no real permission checks going on here, and everyone can see everything. So the last one is probably the most important one. No tests. If you're building these big, extensive formulas, wouldn't it be nice to be able to pass a test case full of like edge case type situations, so you could understand any regressions in your formulas, or if new edge cases actually bring up logic that doesn't make any sense for that specific use case. Excel really doesn't give you an option for doing any kind of testing there. So what do you do instead? Well, of course, we're at a Django conference. I'm going to say Django. I shouldn't have to do a lot of hard selling here to tell people why Django is an amazing product to use. But Django does give you everything you need to get started fast, and including things like the Django admin. That can kind of be our, rough sketching of, an easy way to get a UI on top of some models and some data to get things going. But we want to use Django because we actually care about our data, and we want to get, we care about our data and our business logic first. It's a very stable platform. We've been around for more than 10 years. Python is obviously has a very high security score. So when it comes to the platform itself, we feel like it's a reliable and secure platform to start building upon. And it's easily extendable with add-ons. So there's a great ecosystem of people out there building software for Django itself. And I'll show off some of the stack we used as part of this project. And then you get the ability to do things like scaling. Problem of having thousands of customers can easily be scaled across hundreds of servers. So the ability to scale horizontally or use tools like Celery for long-running tasks, and then you get the right tests. So now you can actually take all of that logic and business understanding and wrap it in sets of test cases that can now be run on an automated process. So every time someone makes a change to those, they can be tested against a set of known good, understood test cases. So looking at the stack that we have put in place for this specific project, obviously we're using the Django backend, but we also are layering into that Postgres. We do like Postgres because it's been robust, reliable, scalable, and it just has worked well for us I can't remember last time we used another one other than Postgres for this kind of relational type of a problem. Adding into that Django REST framework, what we'll want to do is build a rich UI on top of this so that people still have that speed and flexibility or ease of use of what they've become accustomed to with Excel. And kind of, I'll make more note of that later, so you don't want to recreate Excel in the web browser necessarily for people, but you do want to make sure you're building a fast and easy to use app. So see things like using HTMX. In this case, we'll be using React on the front end. So having Django REST framework, which I think is the kind of default REST framework that we can layer right on top of Django, is great. Adding in DRF Spectacular for OpenAI or OpenAPI 3 schema generation. So those who are building the front end, this is really key to have that kind of documentation quickly available to them. And using Django REST framework, simple JWT, so having authentication with JSON Web Tokens as a nice plugin for Django. And then Django Filter is a nice add-on for Django to filter down query sets, based on the model's fields. So making it very easy to write those kinds of queries. So how do you take this the next step now? Then we kind of got a stack of backend software, and I missed one part in there, which is that Next.js UI, so the React-based UI. So we're going to talk through a little bit of that transition, because everyone loves change management. It's a favorite topic of mine. Ask anyone who works at 6 Feet Up how good I am at it. Carol's laughing because I sometimes I just pull the trigger on things maybe a little too quick. But I think you should take this and keep this in mind as you're trying to move people from, I'll take Excel out of my cold dead hands type mode to some kind of a new web application. You're going to want to make sure you do that in a very measured pace. So the optimal stages we found, it's going to be this kind of evaluate, prototype, review, build, and then switch. And let's kind of talk a little bit through each of those pieces specifically. In that evaluation stage, you're going to want to gather every formula you can find inside of those spreadsheets. This may seem obvious, but actually documenting them is probably your top priority. Understanding what people have been, kind of encoding into the opaqueness that is a spreadsheet is kind of tricky. So every formula needs to have valid and invalid examples. So when we get time to go to the testing phase, we have good data about what is good data in there and what is bad data in there, so we can actually write our test cases for when it's implemented in Django. And then add information about the file versioning, cell locations, precedence and dependence. And then actually one of the key bits here is use like a Jupyter notebook to maybe build out and prototype and test some of these things so you can quickly make changes and iterate with whoever your client is, whether it's an internal client or an external client. I will show off that too here. So using Jupyter notebooks, we can let me show you the demo of that. Pull that up here. So in that repository that I linked to at the very beginning, I have a Jupyter notebook in there. Down inside of there is going to be, well, actually, I'll show you the spreadsheet first because it may not be obvious what's going on. Here we go. So this is kind of a mocked up, again, like I said, change to protect the innocent type spreadsheet. But it's going to have some things that are dealing with battery degradation and some of the sample formulas that are in here. For example, you can see here, this starts summing, one of these starts summing the losses of incremental tranche DC output. These are also, don't ask me questions about battery technology. This is not my area of expertise. Ask me questions about the Django part. That's fine. I don't know much about the battery pieces here. But I do know that we were inside of here calculating like these output losses to find the formulas. But this spreadsheet is linked in that GitHub repository, so you can kind of start seeing what we did there. In the Python notebook, we would create doc strings with the cell, like the headers and like the column formulas. We would just put those right in the doc strings, so we knew for this operation, this is where that came from. It may even be some additional things you could do here would be even put the location, like workbook, cell location, like maybe starting cell location, so it's easy to find. Because I saw there I had trouble trying to find where incremental tranche DC output was coming from. In this case, that's actually a static constant. So a lot of times in your notebooks, you're going to have tables of lookup data, constants that are important for the operations you're doing. So I'll show in this demo like importing that kind of content into Django and then being able to use it for these kinds of test cases. So you can see here a couple of these where this one's just a sum. That one's just a set of years. I think the rest, that's the only one big example where we got some formulas, is going to be this incremental tranche DC output. So documenting that in the Jupyter Notebook, being able to run through it. Actually, I'll run through this notebook real quick. So another nice thing about using the Jupyter Notebook is you can quickly and easily import Excel files into pandas and do operations on them. So we're actually creating a data frame and then converting that into data that's more usable by Python. And I'll talk a little more about that too. So here we're opening up that sample database or sample Excel spreadsheet and bringing that in as our specifications. You can then see we looped over and are looking at just making sure the data makes sense. So it's another nice thing with Jupyter Notebooks is you get that real-time feedback as opposed to like push some code, check it, see if it worked. Jupyter Notebooks gives you that real-time aspect of it. I'll get down here to the very bottom. This one's bringing in specific constants that I talked about. The other one was bringing in data. This one's bringing in some of the constants. We'll set those up as constants that we'll use later. So here's again that incremental tranche DC output. It's grabbing that sheet data from some specific areas of the notebook itself, or the spreadsheet itself. And then we bring in, and I'll go down here to the very bottom. What we'll do is, once you've got your formulas built up inside of Jupyter Notebooks, you can then compare with the Excel spreadsheet because you have the Excel spreadsheet data loaded up inside of here. And I'll show that right here. So the very bottom here, we're looking at what Python did and what Excel did. So you've got Excel and Python for what values we expect, so kind of quick visual inspection. And you'll see already we're seeing a rounding error because of number of digits of precision. They're all the same except for that very first one. Who here is an Excel wizard? How many significant digits of precision does Excel give you? Well, I had to look it up because I was curious to know what this is all about. And it's 15, it turns out, which leads to interesting things that if the people who are doing work in your Excel spreadsheets are dependent on some of these limitations of Excel and don't recognize that these exist, you'll obviously end up with odd or different results. Here's an example. I'm going to show a bad example of bad math. Well, bad math. It's doing math based on its current limitations of the platforms in each platform, Excel and Python. This is the example of if you take 1 and you divide it by 9,000. Excel only gives you 15 digits of significance, which is the 15 ones you see there, and then the rest is filled in with zeros. If you take 1 and add it to that result, so this formula here is actually taking this number 1 and adding it to the result of the previous one, you'll see you get 1 and less ones in the decimal part of that, because it's, again, only 15 digits of significance. The 1 is now your first digit of significance there, to here, which is 15 digits. And then if you go to subtract, you're obviously going to get a different answer. This number and this number should be the same because all I've done is add 1 to 1 over 9,000 and subtract 1 from 1 over 9,000. But I have a different rounding there because of the number of significant digits. That's always fun, right? Let's show you something with Python doing that. Actually, I got it right here. If you do this in Python, like 1.1 plus 2.2, why did that happen? Does anybody know? Because it's floats, right? I'm using floating point math in Python, so 1.1 plus 2, you would have expected 3 plus 3. Instead, you're getting 3.3 plus basically 0 afterwards because of the way floating point math works in Python. This is not a limitation of Python. This is actually just how the floating point specification has been derived over time and how the processors actually work behind the scenes to handle floating point numbers. What's the real answer? The real answer is you use the decimal library. So so if you do this instead, 1.1 plus 2.2 you now have a 3.3. And with a specific number of digits of significance here. If I wanted additional accuracy or significant digits in my math, I can actually do that, and you'll see that I get 3.30 because there's 3 significant digits in that output. The trailing zeros are significant in math. I had to go back and learn a bunch of math to do all this kind of projects. I figured at my age I didn't have to go learn rudimentary math, but now all those classes my kids were talking about when they came home from school make sense. And I'm like, cool, I actually understand what's going on here. So keeping that in mind, it's important to understand as you go through and do these various transitions from Excel into Python, you're going to have to keep in mind those significant digits, floating point limitations, the fact that math inside of Excel can round in different ways than math inside of Python are going to make things work differently for you. And that's why you've got this rounding here for that second entry. It's because of the floating point math. Actually, it's because of the number of digits of significance going on here, because that math actually was done with decimals, I believe. If I looked at it in someplace in here. No. You can look at the code and kind of see what's going on there. So that's like one of the big recommendations there. Here we go. So the nice thing about doing this in Jupyter Notebooks is you don't have to set up a full web stack to be able to start playing with it and actually get buy-in with whoever your client is, whether it's an internal party or not. You basically can set this up quickly, recreate that business logic, let them play with it, because you can hand them outputs from the Jupyter Notebooks as CSV or Excel files, so they can actually validate that that's actually what they got is what they expected, and they can give back early feedback. So this is, again, that change management of giving them the ability to give early feedback often is really nice. So the next step after kind of going through the Jupyter Notebook piece is going to be building an actual Django application. And now we're going to transition away from Jupyter. Now we've kind of validated that those business logic formulas are indeed what we wanted. And there's a lot of great ways to get started. There's the kind of quick start for Django. At 6 Feet Up, we maintain our own cookie cutter template called 60 Django. It's just an opinionated way that we look at deploying Django, which includes things like Terraform. It's kind of maybe targeted more towards Amazon, looking at doing things like Kubernetes for local development, and then basically hopefully gives you a fast development experience and an easy deployment. Well, easy deployment. We'll see how easy it is. But it should be fairly straightforward because we've templated it out that way. Now on the front end, this is where I mentioned some of the front end technologies. We chose to use Next.js combined with Ant Design, and I actually wasn't very familiar with Ant Design before we started this project, and actually not super familiar with Next.js. We've been doing mostly React or Angular type work, but Next.js, if you're not familiar with it, I'd recommend you take a look. It's basically an opinionated set of libraries around React, which are nice. So it's kind of the most popular React framework that's out there. You're like, wait a minute, I thought React itself was a framework, but there's frameworks on top of frameworks. So there you go. But it does have support for client and server-side rendering. You get dynamic HTML streaming, file system routing, supports server and client-side data fetching, which is kind of nice because you could have data sources living in the same cluster and actually have the server fetch them, render them server-side, and then give you back kind of the rendered results, so you can actually make the application more speedy and snappy, doing some things on the server versus on the front end. And we can build internal API endpoints to securely connect to third-party APIs. So if you've got internal-only APIs that are not available outside the firewall, it's good support for that kind of thing. Ant Design is basically a React component library. Really beautiful, easy to use library. I think one of the nice things about choosing Ant Design is it actually has a charting extensions or add-on part up to it. So if you do Ant Design Pro, which was a confusing naming to me because I thought Pro, okay, how much does it cost? It's still open source. It's just the Pro version includes more enterprisey, dashboardy things for professionals who are building applications. It's not a paid version of the open thing. It's actually just a professional version of the already open thing. But it has really beautiful charting built in, so you're not bringing in yet another charting library. You can kind of stay inside that ecosystem of the Ant Design and have a common set of UI components that we use on a regular basis. So the whole team's already familiar with them. And it's easy customizing and theming. I mentioned Open API as being important here. If you've got a team working on the front end, it's really nice to be able to give them documentation for the API on the back end even before that is finished. And so having a schema generated from the Open API docs, like with DRS Spectacular, is nice because the front end people can get started before the back end is actually technically complete. So you can kind of mock up a lot of things and actually work at building the front end faster instead of waiting for being kind of roadblocked by the back end only. Another thing we built in for them was things like the PDF and CSV exports. It's nice to be able to give stakeholders a report in a PDF format, or if you're still transitioning from the Excel version of the project into the Django or web app version of the project, some people may want to have those CSV exports so they can maintain parity and kind of run in parallel for a little while until they fully switched over into the Django version of this. All right, what kind of challenges did we actually run into? Well, as you can imagine, as you're working, people aren't just going to stop what they're doing on the Excel sheet, and you can't obviously deliver a full-blown version of this application in a very short amount of time, depending on the scale of or scope of it. So people are constantly updating and optimizing their Excel spreadsheets. Every new version of that Excel spreadsheet needs to be evaluated for inclusion into the refactor to the Django version of the app. Sometimes small changes in formulas can go without notice because they're so obscured behind the cells that they're coded or programmed into. So making sure you're kind of staying in sync with all the changes that the business folks using Excel are doing with your version of the app so that you can kind of start using it along the way is tricky because some people can change things out for underneath you. And then constant change of business requirements is definitely easier to do in Excel than it is in code. So there's a challenge you're going to have to work through is how do you give business users that same flexibility they had before of, oh, well, I just needed to change this one formula slightly. Well, that requires maybe a code change. Or if you wanted to build a framework inside of the Django for documenting those formulas or somehow putting the formulas as part of the data in the database, something to consider, but every one of those instances is going to be probably unique to your situation. I like having the code as Python code on the file system for things like testing, which is kind of nice. And from the UI and front end, there's massive amounts of just tabular data that you have to be able to display. So thinking through the usability of that, how fast it loads, giving them a fast experience. If you didn't see Chris's talk from yesterday about HTMX, that speed is really, really important to getting adoption. Because if they feel like this is a subpar experience from the zippiness of Excel, they may not be as excited to adopt this platform. Another big challenge, obviously, is very long forms. If people are entering a lot of data into those Excel sheets to get things done, those forms can get really, really cumbersome, and you don't want to be recreating a web version of Excel. One thing I did want to show, before I go here, was one of the big benefits I mentioned was using Python was having tests. So if I've got my models, so we've gone from the Jupyter Notebook version of the code, brought that in. There's a couple different approaches you can have to where to put those formulas and how they get tested. You could use fat models where all the logic and the functions or methods on each of the models contain those the formulas from the Excel spreadsheet. Or you could include them in, like, say, utility helpers that are easier to test because maybe you don't need the full database available to you to actually run the unit tests. In the example code on the project, this one has the formulas right inside the model. And so moving the doc strings over, keeping the formulas there so that there's clear documentation about where this came from, also now allows me to write tests. If you all are using, I think VS Code and PyCharm both support the Codium AI add-on, which is kind of nice because you can see this little button here that says test this method. So you literally click it, and that's what I did earlier to produce this set of tests. So it can start building up test dummy data that you can now test inside of your Django application. So if you know what those good test cases or good use cases of data look like and the bad ones look like, you can start building those in here. And that Codium plugin actually kind of nice because it'll recommend 5, 6, 7 kind of base use cases to get your bases covered. As I was playing with this earlier today, I recognized there was already a bug in the Django implementation of this code because we're importing the spreadsheet. Actually, I'll show that as well. We have a management command in that repository that will grab the sheet, the Excel spreadsheet, and do basically what we're doing in the Jupyter Notebook, which is pull that data in, populate some constants. This is where the error actually lives. And if I show you on the web browser, refresh this page, or no, make it bigger so you guys can see it. We just had that bring in that constant data into a single model, and then we were using the JSON field for some of that like larger data that we would want to use in some of these calculations. There's a problem here. It's like we were using integers as keys inside the Excel spreadsheet for a number of years. JSON, according to the specification, does not support integers as keys. It's like got to be a string. So it got magically transformed into a string. Through writing the test cases, actually, I found that. So I came back here, and if we run the tests, which is nice because the tests run fast. It imports the data, and you can see in here that, well, actually, I started fixing that problem and got into the next problem, which was my test data didn't match the sample data. So now you need to start adjusting the sample data that Codium produced for me. But I actually have failing tests that can now be fixed, which is a great head start opposed to Excel, which has no tests at all. So just there's some example code that will be shared as part of that repo as well. Oops, there we go. Now, if you have the luxury, you should use Django from the beginning if you can, but you may not always because a lot of these things are scrappy startups or a business unit that just wanted to get going, and so they're going to use Excel to get started, and you're going to have to deal with it. But transition to Django as early as possible because it's going to give you a lot of benefit for multi-user environments, having that sharing, scaling. It's just definitely the way to go here for using that. Now, if there's any questions, oh wait, I've got one more slide over here, which is again that link to, there's a blog post on the 6FeetUp site that was about this project specifically, goes into maybe a little more detail in some specific areas, and then that's the link again to the repository for this project, and you can always find me in all the various places. So if anybody's got questions, I think we have a few minutes left still for questions, and we can use the microphone. Questions?
Yeah, thank you. You talked about the challenge of working in parallel while people were changing the Excel files and having to update the Python code. So GitHub isn't able to compare Excel files. How did you capture what the changes were when they happened?
That's a really good question. I didn't work 100% on that project when they were doing this. So I just know that they were responsible, the client was responsible for sending us updates to the Excel file with a change log. And it may be common in your org that there's a worksheet page at the very beginning that kind of notes the version history of that file. So as long as everyone is very consistent with how they track those changes and log those on maybe a worksheet in the front that gives you date, who did it, and maybe some description of the change, like commit log for an Excel sheet, that's going to be it's still very, very manual when it comes to tracking that change.
That sounds really hairy. The other question that I have for you is, if you're interested in energy at all, are you following any podcasts or anything like that you particularly like about energy policy, about batteries, about all this stuff?
I am not on any about that, but I would love to participate in those. Question over here.
So when you've got a bunch of data in from Excel, you've got the people using a Django system now. Maybe they're comfortable in the Django admin, maybe they're not. But a lot of times when I've dealt with similar problems, I get feedback that they want to be able to see the data in a big table like Excel.
Yeah.
Are there any admin plugins or tools to quickly add that UI element so they can see a bunch of tabular data to visually inspect it?
I'll have to get you what plugin. There was a React like plugin we liked for AG Grid, I think is what they were using for the kind of an Excel-like editing experience. Again, keep away from it if you can, but if they're really insisting on having that experience, you obviously don't want to hand them the Django admin and have them just clicking through that. But there are some nice React components for doing spreadsheet-like things that you can even make editable.
You said AG, what was the name of it?
AG Grid,
AG Grid.
I believe, is the one we used for another project where they had exactly that concern. They're like, we just want a big table to edit. I'm like, ugh. Okay. At least the formulas are still testable at that point. Like, any other questions?
One thing you can do is to wire up Django to talk to Google Sheets API or Microsoft API and use their cloud storage as the data backing for your Django app instead of importing the data directly. It seems like that would solve some problems and open up another class of problems.
It did, especially on this case. We couldn't even use the Excel online version of the app. They were strictly using the desktop Excel application because of some limitations. Like you had to have something they were doing in their formulas didn't allow us to even do that. But I think that might be a good option. You're going to deal with a lot of like synchronization and potential data consistency issues as you go back and forth between Django and Google Sheets or even Microsoft Excel online, I think. Awesome. You have any more questions? Well, thank you all very much. I'm again excited to be here. And if you see me in the hall, feel free to ask me questions. Happy to chat about this or the lightning talks or BEST or any other thing I've talked about. If you've got stories about going from Excel to Django and I'd love to share them as horror stories, I'd love to hear them. So come find me afterwards. Thanks again.